Hi, today we're looking at section 5.2, which deals with frequency tables, histograms, and frequency polygons. So we'll look at some definitions and do an example. So we have what are known as frequency distributions. So they're a set of intervals usually of equal width into which data is organized. So for example, if you're looking at, say, precipitation, you might have amount of times it rained between 0 and 2 millimeters, amount of times it rained between 2 and 4 millimeters, amount of times it rained between 4 and 6 millimeters. So that would be our intervals would be, in this case, intervals of 2 millimeters. Now, we then have a frequency for each of those intervals that indicates how many times a measurement in that interval has occurred. So we'll look at how that data is then sometimes graphed, which is in a histogram. So histograms are like bar graphs. However, instead of representing just one thing in the bottom of a bar graph, the histograms, the bottom represents a range of numbers. So in this case, we have a graph that scores as a percent on a final exam. So they have 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So each bar represents a score range of 20. And then the height of the bar is represented by how many students scored in that range. So essentially, it's like a bar graph, but all the bars are touching each other, and the bar and across the x-axis, instead of representing one particular thing, it's representing a range of numbers. So we will do an example where we compile data and then come up with our own histogram. So for example, create a frequency distribution table with this data. It is the rainfall here from back in December 2011 to November 2012. So 1 year worth of data. And how much precipitation there was each month. So based off the numbers in this, I might do ranges of 20 millimeters when I create the data table. So what I tend to do when given data like this is create essentially a 3-column table. This first one will be our title of what we're measuring here. So we had precipitation. This one I'll just call tally because as we go through, I'll mark little tallies in. And then over here, we'll have our frequency, which we add up those tallies. Now, based off information here, I might go in intervals of 20. So this would be, for example, 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 to 120, 120 to 140, 140 to 160. So as I go through, I'll mark where each is rounded. So we have 13.4, so that would go in 0 to 20. We have 34.4, so I'd go in 20 to 40. 9.3 would go 0 to 20. 18.8 would go in 0, or sorry, would be 0 to 20. 42.2 would be in 40 to 60. 49.2 would also be in 40 to 60. 84.5 would be in 80 to 100. 22.1 would be in the 20 to 40. 23 would also be in the 20 to 40. 2.6 would be in the 0 to 20. 146.5 would be in the 140 to 160, and 52.2 would be in the 40 to 60. So now we'll fill out our frequency column. So 0 to 20, it occurred 4 times, 20 to 40 3 times, 40 to 60 3 times, 60 to 80 did not occur, 80 to 100 occurred once, 100 to 120 did not occur, 120 to 140 did not occur, and 140 to 160 occurred once. So we have created a frequency table with this data. Next, we will create our own histogram using this frequency table. So we want to create a graph using our frequency table. So first I'll draw in some axes. And then we need to label this and figure out what value should go across it. Now, essentially our precipitation, we went up to 160. So might quickly count up how many lines we have here. Okay, so each one of these could represent 10. So down here we're at 0. Here we'd be at 20, 40, 60, 80, 100, 120, 140, 160, and this was our precipitation in millimeters. Now we always want to make sure we label that. And then on this side, we'll have frequency. Now, our highest frequency was 4, and we usually want to have our graphs filled out a fair amount. We don't want just all of our bars in the bottom, so we'll find a scale that utilizes most of this graph paper. So I might say every 4 boxes is equal to 1. So this would be 1. This is 2. This is 3. This is 4. Okay, so now we'll start filling this out. So from 0 to 20, we had a frequency of 4. So 0 to 20, we have a frequency of 4. Next one, 20 to 40, we had a frequency of 3. So 20 to 40, we had a frequency of 3. Next one, 40 to 60, we also had a frequency of 3. Next one, 60 to 80, we had 0. Then 80 to 100, we had 1. So 80 to 100, we had 1. Then we had 0 for 100 to 120 and 120 to 140. And then we had 1 for 140 to 160. So from 140 to 160, we were at 1. So this is what our histogram for that data would look like. Okay, so next, we'll talk a bit about frequency polygons. These are simply line graphs. So we plot our points and then join them with lines. Now, essentially, if it's from a frequency table, then our point along our x-axis will line up with the middle of our frequency range. So we'll go back to a previous graph and just draw in what a frequency graph for, or sorry, frequency polygon for this would look like instead of a histogram. So if we are doing a frequency polygon instead of having it for the whole interval, halfway between 0 and 20 is 10. So we'd have it here at our frequency of 4. Then halfway through here, we'd have this. So essentially, we would have our points halfway through the tops of these bars. This one didn't have anything, so we're down here. This one would be here. This one's here, this one's here, and this one's here. So if we were doing our frequency polygon, we'd then just join these. And that would be our frequency polygon.